Hello friends, this video on electrochemistry part 2 is brought to you by examfear.com. No more fear from exam. Right? Why? What happened? So it started in 1663. A German physicist, he created first electric generator. He created the first electric generator and it was based on friction. So 1663, before 1663 there was no electricity at all, right? 1663, this guy, German physicist Otto von Guericke, he created electric generator and they produced static current. It produced static current by applying friction. The next was since 1785, this guy Charles de Coulomb, he developed the law of electrostatic attraction. And we will discuss this laws actually. And then in 1771 actually, a doctor, please note he was a doctor, he was not even a chemist or he was not even a physicist. He was a doctor and his name was Galvani. He marked the birth of electrochemistry and that's why he is called father of electrochemistry. He was the guy who gave the birth to electrochemistry. He was the one who established the bridge between the chemical reaction and the electricity. If you see, electrochemistry is nothing but this is the chemistry and it's electricity, right? So he was the one who established the bridge between chemistry and electricity. How he did that? He did that incidentally actually. He's the guy, Dr. Galvani, and what funny thing happened was one fine day when when Galvani was cutting a frog's leg, you see this is the frog leg which he was trying to eat, right? And he was using the steel scalpel. This steel scalpel touched the brass hook and this brass hook was actually holding the leg piece. This can happen, right? When you eat this frog and this frog is generally in the brass hook, when you're trying to cut, he was trying to cut with the steel scalpel. The funny thing happened was the leg of this dead frog twist, right? This is the dead frog. The leg of this dead frog twist. So he did the experiment once again. He took two different metals, right? For example, he has steel and brass. So he took two different metals, zinc, silver. I mean, just it has to be two different metals. And the moment you touch in a dead frog, the leg twist. And that was a little strange, right? Why did the leg twist? So this guy thought there is something called animal energy, animal electricity actually. So he coined a term called animal electricity. Because he was a doctor, he knew more about animals. So he told, okay, there is something called animal electricity, and that was the reason why this frog the leg is twisted. Correct? So the funny thing happened was, let me explain once again, when he was eating this frog, dead frog, and this was a brass and it was a steel he was trying to cut, and this jumped, actually not jumped, I can say the leg twisted. He performed the experiment again in the lab with two different metals and he saw that the leg twist and nobody knew from why this leg twist. So he coined the term called animal electricity, in fact a different branch of chemistry altogether where you talk about the electricity in animals, right? So he thought that is the reason why the leg is getting twisted. But this guy Volta, he believed that this whole experiment, it happened not because of animal electricity. He told there is nothing called animal electricity. This happened because of the metals. This happened because of the metals. So what he proved that if you are using same metal, let's suppose two steel metal, the leg won't stitch. If you are using two silver, right, both silver, the leg won't twitch or the leg won't shake, right? The dead frog's leg will shake only if you use two different metals. That was he proved. But he wanted to prove that in a more concrete way, right? He was very much determined now. He knew something is going wrong here, right? If you use two different metals, some electricity is coming out. Because of the electricity only, this frog is shaking its leg, the dead frog. So he was determined to find the electricity using the combination of two different metals, right? It was two different metals. So what he did was he did a lot of experiments, and as I told, he found that it was two dissimilar metals, and not the frog leg actually that produced electricity, because there was electricity here, there was no doubt in that, but it was two different metals, not something which is there in the animal. So he was telling that there is nothing called animal electricity. It was two different metals that produced electricity, right? And he was telling that the frog leg was just indicator of the presence of electricity. The frog leg was nothing but indicator that there is electricity, correct? To prove it, he built the first battery. He built the first battery, and that battery is called Voltaic pile, right? Because he wanted to just prove his theory. To prove that, he created something called Voltaic pile. So let me explain you what is Voltaic pile. I mean, I'll explain that Voltaic pile in next few slides. Let's understand what happened after that. And also note that since this guy Volta was very popular actually, because he was the guy who created the first battery, right? The SI unit of battery, SI unit of current, if you see, is volts, right? The battery, SI unit of battery actually. It is in volts, 1.5 volt, 2 volt, like that. So this volt is nothing but in the name of Volta. Correct. So after that, I'll just continue the history, then we'll discuss the Voltaic pile. So the history continued, and in 1800s, these people were they succeeded in producing they succeeded in decomposing water. So they did the electrolysis of water, right? They did the hydrolysis of water actually. And then soon after that, this guy Ritter, he discovered the process of electroplating, where you have one metal, for example, if you see copper, there is some other cheap metal, and this is electroplated with copper. And then Faraday gave the law of electrochemistry. We'll discuss the Faraday law also. And then this John Daniel in 1836, he invented the primary cell. So the earlier issue with the Voltaic pile, which I'll explain you, was the hydrogen gas was bubbled actually, and that leads to polarization of battery. I'll tell you what is polarization of battery, right? Polarization of battery, and because of the polarization of battery, the battery doesn't, I mean, it doesn't work after some time. So it had very less efficiency. So he eliminated this hydrogen gas in his setup. We'll explain this Daniel cell also. And then we have this William Groove. He produced the first fuel cell in 1839. So that's all we have for the history. And then this guy came in 1888 to give the Nernst equation. So if you see, in all this other cell I've discussed, they used to take 1 molar concentration of all the electrolytes. So this guy came up with a relation, right, on what happens if you take 2 moles of electrolyte or 3 moles of electrolyte. There has to be some relation in the volts. So he came up with this Nernst equation. We'll discuss this also, right? As I told, let's discuss the Voltaic pile first. So Voltaic pile was the first battery which was which could continuously provide electric current to a circuit, right? So he believed, as I told, he believed that the electricity came from the contact tension between two metals. So he chose two metals. Rod. He chose two metals plate actually instead of rod. If you see, there are n number of metal plates here. Why? Because he thought that the electricity came because of the contact tension. So if you see, what he did was, so this Voltaic pile was invented by Alexander Voltaire in 1800, and why it happened was, as I just explained that. So this Galvani, this Dr. Galvani, he discovered that while eating frog, he saw that this legs twist, and then experimentally he proved that the dead frog, if you use two different metals, the leg twist. So he was excited with this experiment, but he confronted Dr. Galvani. Dr. Galvani told that there is something called animal electricity inside the frog, but he confronted saying that there is something in the metal which produces electricity, right? So just to prove his theory, what he did was he created this voltaic pile. And to do that, what he did was he demonstrated that when two metals and the brine soaked cloth, brine is nothing but sodium chloride, right, salty water, that is arranged in the circuit, they produce electricity, and they arrange in this pattern. And just he believed that the electricity is coming from contact tension between two metals. He didn't use rods, right? He used plates. If you see, they are all plates like this. He used so many plates, metal plates, and he used actually zinc and silver plates. And if you see, he has piled up these plates in this pattern. So this is a metal one, this is a cloth, and there is a metal 2. Again there is a metal 1, there is a cloth, and then a metal 2, and like this it continued, right? And this cloth is nothing but the leather which is made wet or using the brine solution. Now what happened was, if you connect this guy and this guy, the electricity was produced. If you see this guy and this guy, if you connect, it produces electricity. So the reaction that took place was, for example, this is my zinc. So at zinc, what was to happen was, zinc used to get oxidized to Zn2+, and 2 electrons were emitted, because zinc is more stable in +2 form. We'll explain this when we talk about the reduction potentials. So zinc used to get oxidized, and here at silver, so we have silver and we have, let's say, hydrogen. So in this case, at this metal 2 point, what will happen is my hydrogen plus will take the electron to form hydrogen gas. So if you see, oxidation reduction both are happening here, right? And with this, the current will pass. We'll understand more about this when we talk about the Daniell cell. But there was a limitation, the first limitation was that the hydrogen gas was produced at cathode. So at this point, at this all this red, right, all the hydrogen gas was produced, right? And there's a limitation to the number of plates, because if you increase the number of plates, so this soaked leather or soaked cloth will squeeze, and that is not good. And the third limitation was the plates used to get rusted easily. So rusting a plate was an issue. There were 3 concerns. One was the hydrogen gas. So it causes polarization. So because of hydrogen gas, the battery used to stop working. And then after maybe 1 or 2 hours, and the limitation on the number of plates, and you can't have a number of plates, because the moment you increase the plate, this soaked cloth or leather used to squeeze, and this plates used to rust easily. There were 3 limitations to this voltaic pile. So we see at zinc we have more electrons, and at this metal, maybe silver, this is silver, red one is silver, at this we have less electrons, correct? So at this we have less electrons. So zinc has more electrons, this has less electrons. So if you connect this via circuit, the electrons will flow from here to here, and thus you will generate electricity. It's a very simple logic. Zinc has more electrons, zinc plates, so silver will have less electrons. So we connect the plate, the electrons will flow from zinc to silver, and the current will flow in reverse direction. But there was the issue with, one was the hydrogen gas was the issue, the rusting of plate was the issue, and the third issue was the number of plates. So the volt, you can have much number of huge volt. The number of plates was the issue. There was a cap to the number of plates. Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.